Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi again. In this lecture video, we want to look at topic 4.3, definite integral. The concept of definite integral links with the concept of area. However, in this lecture video, I'm not going to discuss in detail about this concept. If you want to know more about this concept, you may refer to any reference books or any reliable sources from the internet on your own. The definite integral is denoted by integration from a to b fx dx, where a is the lower limit and b is the upper limit. And the result, which is the antiderivative capital Fx, we will then substitute x with b. Therefore, we will evaluate Fb minus Fa. So this will be the result of integration from a to b fx dx. Before we see several examples involving definite integrals, let us look properties of definite integrals. Let k be a constant. If fx and gx are continuous functions on the interval ab, then the integration from a to a fx dx will be equal to 0. In this case, the lower limit is equals to a, and the upper limit also equals to a. So lower limit, it is equals to upper limit. And when the lower limit is equals to the upper limit, then the result of the integral will be equals to 0. The second property, integration from a to b fx dx, it is equal to negative integration from b to a fx dx. In this case, the limit is switched. The original integral, we have the lower limit is a, but in the rewritten result, we have the upper limit is a. In contrast, from the original integral, we have the upper limit is b, but then it become the lower limit is b. So this is the second property of definite integral. The third property, integration from a to b k times fx dx, it is equals to k times integration from a to b fx dx. In this case, the constant k is factored out. The fourth property, we have integration from a to b fx dx. It is equals to integration from a to c fx dx plus integration from c to b fx dx, provided that c is greater or equals to a, less or equals to b. And if you see here, we have the lower limit is a and the upper limit is b. So the intermediate value is a value between a and b. The next property, we have integration from a to b fx plus or minus gx dx. It is equals to integration from a to b fx dx plus or minus integration from a to b gx dx. In this case, we split the function into two parts of integration. Okay, now let us see the first example. Okay, our first three examples will be based on tutorial 4. Let us look first question 4a. In question 4a, we have the integration from 1 to 2 x squared plus 1 over square root x. So what we have to do first in this question is we need to rewrite the function. Okay, so it is equals to integration from 1 to 2, where we will split the function into two parts, where x squared over square root x plus 1 over square root x. dx. Sorry. Where this is equal to integration from 1 to 2. We not yet integrate it. We just rewrite it first. Where x squared minus 1 over 2 plus x power of negative 1 over 2 dx. Where this is equal to integration from 1 to 2, x power of 2 minus 1 over 2 is 3 over 2 plus x power of negative 1 over 2 dx. Okay, now each part here, if you see, it is based, we can use this formula. Integration x power of n dx, it is equal to x power of n plus 1 over n plus 1 plus c. Okay, but in this, But in this example, since we are dealing with definite integral, then we don't have this constant c. So what we will do next is, this is equal to x power of 3 over 2 plus 1 over 3 over 2 plus 1 plus x power of negative 1 over 2 plus 1 over negative 1 over 2 plus 1. Where this is equal to x power of 5 over 2 over 5 over 2 plus x power of 1 over 2 over 1 over 2. And next we can rewrite this as, oh, I missed the limit, sorry. Okay, where x is from 1 to 2. Okay. And then here also, we have x is from 1 to 2. So now we will rewrite this so that it will be easy for you to calculate. So 2 over 5, x power of 5 over 2, plus 2 square root x, where x is from 1 to 2. Okay, first of all, we will substitute x equals to 2. Okay, based on this, where this is equal to 2 over 5, 2 power of 5 over 2, plus 2 times square root 2, minus 2 over 5, 1 power of 5 over 2, plus 2 power of square root 1. Where this is equal to 5.0912. The first part is 5.0912 if we round off to 4 decimal places, minus 2.4. Therefore, this is equal to 2.6912. So this is the final answer for question 4A. Next, we want to look at question 4E. Okay, in this case, our function is a trigonometry, which is secant x. Okay, we know that the integration secant x dx, it is equal to ln modulus secant x plus tangent x dx. Sorry, tangent x. Where x is from pi over 3 to pi. Okay. This formula is, you can obtain it from your formula book, page 24. where now we will substitute x equals to the upper limit first, which is pi. So ln. Oh, but before that, if you look our function here, this one, this is secant x, but you don't have secant x function on your calculator. So we need to rewrite this so that you can use your calculator to find secant x. Okay, we know that secant x, it is equals to 1 over cos x. So 1 over cos x plus tangent x modulus, where x is from pi over 3 to pi. So now then we can substitute x equals to pi. Therefore, ln modulus 1 over cos pi plus tangent pi minus ln modulus 1 over cos pi over 3 plus tangent pi over 3. Okay, what's next? So then you can press your calculator. You'll find that for the first part, we have ln modulus -1 plus 0. Make sure when you press your calculator, you choose the mode is radian. Okay. Minus ln modulus 1 over 0.5 plus 1.7321. So modulus -1 will be +1. So ln +1 minus ln 1 divided by 0.5 is 2. So 2 plus 1.731 will be, we will get plus 1.7321, we'll get 3.7321. So ln 1 minus ln 3.7321 will be, ln 1 is 0 minus 1.3170, round off to 4 decimal places. We get 1.3170. Therefore, the final answer is negative 1.3170. Next example. Okay, this question is based on tutorial 4, question number 5G. Okay, in this question, we have the function is involving exponential. Okay, this is equal to integration from 0.5 to 1. Okay, we will rewrite this first. So 3 cubed is 27, and e power of x cubed is e power of 3x dx. So we have the constant 27, so we will factor out 27, e power of 3x dx. Okay, we know that integration for e power of kx dx, it is equals to e power of kx over k plus c. Okay, this formula is it can be found from your formula book. And we know that we are dealing with definite integral, therefore we don't have this plus c, so we can ignore that. Then let us go back to our question. So 27, integration e power of 3x will be e power of 3x over 3, where x is from 0.5 to 1. Okay, here we have 1 over 3. We will factor out 1 over 3. So we get 27 divided by 3. And then e power of 3x, x is from 0.5 to 1. So 27 divided by 3 is 9. So 9 e power of 3x, x is from 0.5 to 1. Okay, first of all, we will substitute x equals to 1. Then you'll get it is equals to 9 e power of 3 minus e power of 3 times 0.5, where this is equals to 9 e power of 3 minus e power of 1.5. Then we have this is equal to 140.4346. Round off to 4 decimal places. Right, next example. If integration from 0 to 4 negative x squared plus 9 dx, it is equal to 44 over 3, and integration from 4 to 3 negative x squared plus 9 dx, it is equal to 10 over 3. What is integration from 0 to 3 negative x squared plus 9 dx? Okay, based on this question, we know that we can use this property of definite integral, this one here, okay, the fourth property. So therefore, okay, solution, integration from 0 to 3 negative x squared plus 9 dx, it is equals to integration from 0 to 4 negative x squared plus 9 dx plus integration from 4 to 3 negative x squared plus 9 dx. If you see here, we have the upper limit for the first part is equal to the lower limit of the second part. Okay? And then the lower limit for the first part is equals to the lower limit of the original integral, and the upper limit of the second part is equal to the upper limit of the original integral. Okay? So we know that the integration from 0 to 4 negative x squared plus 9 dx, it is equals to 44 over 3. And we know that the integration from 4 to 3 negative x squared plus 9 dx, it is equals to 10 over 3. So from here we have 54 over 3, where 54 over 3 is equal to 18. Alright, that's all example for topic 4.3 definite integral. Bye-bye.